Hello students. One of the important topic of double integration is changing the order of integration. We'll see how to change the order of integration of double integration and evaluate it. The first step of changing the order of integration is identifying the region by using the given limits. Then shade the region. Then to find the limits for the changed order, we need to draw a strip parallel to x-axis, horizontal strip, if you want to change the order as dx dy. Or if you want to change the order as dy dx, draw the strip parallel to y-axis called as vertical strip. Then using the strip, we need to find the new limits. Then we need to rewrite the given double integration as changed order of integration like this. So with the example, it will be clear for you. First example, changing the order of integration and evaluate it. We need to change the order of integration. So the given order is dy dx. First we need to fix the limits, check the order, whether it is in the correct form. Then we can change this order. So see the inner integration, the limits are from x squared to x. So the variable x is there, so we need to fix these limits for the variable y. Then remaining limits you need to fix for x. So inner integration, they are the limits for y. So inner integration should be with respect to y, outer should be with respect to x. So given order is in the correct form. So next we need to take the given limits and identify the region. Okay, it's not coming. Okay, that straight line should come there. Okay. Okay, one straight line you need to draw this here. Okay, anyway, so this is x is equal to one straight line. So the blue color shaded region is the a region of double integration. Now we need to change the order of integration. So let us assume a strip parallel to x-axis for changing the order. Changing the order means we need to change the order as some function is there. Order should be changed as dx dy. So I am assuming a strip parallel to x-axis, horizontal strip. The lower end of the strip meeting the straight line, that gives the lower limit. Upper end of the strip meeting the parabola, that will give the upper limit of x. So x is equal to y is the lower limit, and upper limit is the parabola whose equation is y equal to x square. Solve this for x. You will get the limits for x as root y plus or minus root y. As the region is in the first quadrant, it is x is equal to root y, and it is bounded by the next y limits. So see the entire region, it starts from the origin. So y is equal to 0 is the lower limit. It ends at the point 1 comma 1. It ends at the point 1 comma 1. So upper limit is 1. So these are the new limits. So the changed order is double integration. Outer integral is from 0 to 1. Inner integration is from y to root y. The integrand is x. The order is dx dy. So up to this, it is changing the order of integration. Next we need to evaluate this. So to evaluate this, retain the outer integral as it is. Inner integration is with respect to x. So integrate the integrand with respect to x. If you integrate, you will get x squared by 2. Limits are from y to root y. Retain this dy as it is. Now substitute the upper limit. Upper limit is root y, the whole square is y, minus lower limit is y. If you substitute y, you will get y square dy. Now 1 by 2 is common. Next we need to integrate this with respect to y. So if you integrate y, you will get y squared by 2 minus integrate y square, you will get y cube by 3. Limits are from 0 to 1. So substitute the upper limit minus lower limit. Upper limit is 1, so 1 by 2 minus 1 by 3. Lower limit is 0, does not exist. So you will get it as 1 by 2 into 6, and this is 3 minus 2, 1. So altogether it is 1 by 12. So the value of the integration is 1 by 12. So this is how you need to change the order of integration and evaluate the double integration after changing the order. So next you can try these two examples. So this one, first one, it is in double integration. Integrand is not given, that is 1, and order is given as dy dx. We need to change this order as double integration dx dy. So first step, you need to identify the region. So lower limit is y equal to x square. It is a parabola about y axis, vertex at the origin, and upper limit is y equal to 2x, which is a straight line passing through the origin, and x is equal to 0 is y axis, x is equal to 2 is a straight line parallel to y axis passing through the point 2, 0 in x axis. So the region is shaded here as in gray color. So this straight line is y equal to 2x straight line, and this is the parabola y equal to x square. So then we need to change the order of integration. So we should assume as to parallel to which axis? X axis. Then lower end of the step gives you lower limit, upper end touches the parabola, that will give you the upper limit of x. So accordingly, the region starts from 0, 0, ends at the point 2, 4. So that will give you the y limits. Okay. So the order of integration is double integration dx dy. X limits are from y square by 2 to root y, and y limits are from 0 to 4. Then you need to evaluate this and get the value of this. Similarly, try this, the next one. Inner integration lower limit is y equal to 0. As the variable x is there, you need to fix these limits for y. Outer integral you need to fix for x. Outer integral you need to fix for x. Then the region should be shaded by applying the given limits. So given limits, in inner integral lower limit is x equal to 0. From x equal to 0, that is from x axis, up to this curve is y equal to root of 4 minus x square. Squaring on both sides, you will get y square equal to 4 minus x square implies x square plus y square equal to 4, which is a circle. Center at the origin, radius 2. So in between the x-axis and circle, that is upper semicircle, bounded by x equal to 0 and x is equal to 2. So x is equal to 0 is y-axis, and x is equal to 2 here it is shown in dotted line. So region in between this is the in between these 4 limits is the region. Okay. So now we need to change the order of this as dx dy. So we should take a step parallel to x-axis. Lower end is meeting y-axis, upper end is meeting the circle. So that will give you the limits for x. Then after changing the order, identifying the limits, evaluate it and get the answer. Next we are going to see next example how to change the order, but we need to divide the region here. So when to divide the region, this example will be easy for you to learn that. So consider the double integration. Integrand is x into y dx dy. Inner integration variable y is there, so you need to fix these limits for x. Outer integral you need to fix for y. So the order is dx dy here. So it is in the correct order. Then after checking this, consider the given limits. So given limits are x varies from x equal to y to x equal to 2 minus y. X equal to y is a straight line passing through the origin. X equal to 2 minus y is also a straight line. So substitute x as 0, get y, plot the point. Substitute y as 0, get x and plot the point. Connect 2 and extend it, you will get the straight line in the graph. Then outer integral limits, y varies from 0 to y equal to 1. So using these limits, we need to sketch the region. So the region will be like this. In between the straight line, okay, passing through the origin, and the straight line is passing through the origin. Scaling should come here. Okay, passing through the origin. So it should, otherwise it should be like this. come like this and it should cut like this. So I think this is not right. So I'll move on to previous page is the next page and we'll draw the diagram here. X-axis, origin, y-axis, and one lower limit is x is equal to y. So straight line passing through the origin, x equal to y, and another straight line is x is equal to 2 minus y. So it intersect the x and y axis are 2 units. So I'll take 2 units this side, 1, 2, and 2 units that side. So the straight line will come like this. This is 2 and the center is 1 and here it is 0, 2. Okay. So in between these two straight lines bounded by y equal to 0, y equal to 0 is x-axis and y equal to 1. This point of intersection is 1, 1. So that y equal to 1 straight line will pass through this point. This line is y equal to 1. So therefore the region is bounded by all these 4 limits. I'll shade it 1 minute. Okay. So this portion is the region. Okay. Now after sketching the region, we need to change the order. So the changed order is double integration. We need to change the order as dy dx. Integrand is xy. We need to change the order as dy dx. So we need to get the limits for y first. So take strip parallel to y axis. So a thick line parallel to y axis. So if you draw a thick line parallel to y axis, lower end is meeting x axis, upper end is meeting the straight line whose equation is x is equal to y. And the same strip, if I move from one end to another end this side, I'm drawing that here. Lower end is meeting the x-axis same, but upper end is meeting the straight line x is equal to 2 minus y, not the same straight line. So from where the change occurs means after this point 1, 1. So you need to divide the region into 2 portions about this point, about this line. So the equation of this line is x is equal to 1. That is dividing the region into 2 regions. So name the first one as region 1 and second one as region 2. So now we are having 2 regions. So we need to get the limits for region 1 and region 2. So first y limits and then x limits. So for region 1, y starts from lower limit, lower end of the strip is meeting x-axis whose limits are y equal to 0. Upper end is meeting the straight line y equal to x. And the region starts from the origin, so x is equal to 0. It ends at the line x is equal to 1, this green line, whose equation is x is equal to 1. Then for region 2, first we need to write the y limits. So lower limit is touching the x-axis whose equation is y equal to 0. Upper limit is touching the straight line x equal to 2 minus y. So solve this for y, you will get it as 2 minus x. Then we require x limits. Second region starts from x is equal to 1. It ends at x is equal to 2. It ends at x is equal to 2. So these are the limits for two regions, region 1 and region 2. So the given limits are from 0 to 1 to y to 2 minus y. This is the given problem. So that we are changing the order. So by changing the order, the region is divided into 2 portions. So according to first region, the limits are from 0 to x to 0 to 1. Integrand is xy. Order is dx dy plus double integration 1 to 2, 0 to 2 minus x. Inner integration 0 to 2 minus x. Xy is the integrand, order is dx dy. Then simultaneously both the integration you need to evaluate and check whether you are getting the answer is 1 by 3. So first integration you will get it as 1 by 8 plus second integration you should get it as 5 by 25.